Alright, let's go ahead and move on to section 2D.2 and 3, which are applications of the geometric sequences. One of the applications that we'll take a look at in particular is compound interest. Now, before we go ahead and take a look at how we calculate compound interest using geometric sequences, let's make sure that we have an understanding of what compound interest actually is. Now, say for example, if you have an investment, in other words, you're taking this money that you have, which is, let's just say 10,000 yen, and we are going to put that into the bank. Now, when you put money into the bank, being that you're giving the money to the bank is going to give you an interest rate, okay? And so what happens then is this becomes, let's say for example, a 5% interest rate paid annually, which would be abbreviated by PA. So what that means then is that when you put the money into the bank, you let it sit for 1 year, and after 1 year, they're going to give you 5% of this amount and give you that money, because that's what they're going to do in order to entice you to put more money into their bank. So let's say, for example, we have 10,000 yen. The bank tells me they will give me a 5% interest rate paid annually. And what I'll do then is I'm going to leave that money in the bank. I'm not going to make any withdrawals whatsoever, and I'm just going to let the interest build. Now, how much money will you have at the start of the 10th year? Okay, so how does this actually relate to geometric sequences? So let's take a look at how this all works. Now, of course, we know that a geometric sequence is going to be described by u sub n is equal to u sub 1 times it by r to the n minus 1. Now, let's go ahead and take a look at this example here, and let's just try to break it down and see exactly how much money we have at the beginning of that year. So say, for example, at the beginning of the first year, which means that I'm just putting the money into the bank, I really just have 10,000 yen. Okay. Now, let's say, for example, that we let that money sit in the bank for 1 year. So that means then, at the beginning of the second year, what the bank will do is they will give me 5% interest of this amount, and they'll actually add it to my amount in the bank. So what that means then is really, if they're going to give me money, that's really 105% that I'm going to receive, or that's how much I will have in the bank after they give me an extra 5%. So what that means then is that really what's going to happen is that this number here is going to be multiplied by 1.05, which is the same thing as 105%. So the amount of money that I will have at the beginning of the second year, after 1 year has been completed, is this amount. And there you go. That's how much money I'm actually going to have in my account at the beginning of the second year. Let's see what happens at the third year. At the beginning of the third year, basically I take what I have here and I apply the same idea, and the bank is again going to give me 105% of whatever I had in the bank account at the start of the second year. So what I have then is I have this amount here, which is what I had in the second year, and they're going to give me another 5% on this total amount. So I multiply this by 1.05 to the first again. Okay, well, let's go ahead now and simplify this. What does this come out to? This actually comes out to 10,000 times it by 1.05 raised to the second power. Okay, and that pattern is going to continue on and on and on. And I'm hoping that you can recognize at this point that this is going to be the same. The percentage rate, of course, being that it's paid annually and is fixed, is also going to stay the same. And the only thing that's changing right now is how many times we are actually multiplying 1.05 to 10,000. And if we go ahead and take a look at this, this is at the beginning of the third year, we're actually multiplying 1.05 to the second power, or multiplying it twice. So what that means then is that if I actually go ahead and say, oh, well, okay, let's instead go ahead and investigate what happens when I actually do n. After n years, how much money will I have at the beginning of that year? So if I just continue with this pattern here, I should have 10,000 times it by 1.05 raised, well, this has to be 1 less than that n value, so that's n minus 1. Now, if we go ahead and just think about what this means, then is that I can actually go ahead and talk about this as a u sub 1 value, which is my initial investment. This is a u sub 2 value, which is how much I have at the beginning of the second year. I can call this u sub 3, and I can call this u sub n. So notice what we have here then is we have basically the same formula that we have here. We have u sub n is equal to u sub 1 times it by r raised to the n minus 1 power. And in this particular case, this represents how much money we have at the beginning of that year. This is the initial investment. This is the percentage rate that you're going to receive, which is the 100% plus the 5% interest that you receive. And this is just going to be n minus 1. So let's go ahead then and answer this question that we have. It says, how much money do you have at the start of the 10th year? If that's the case, we just need to let n be equal to 10. So what we have then is u sub 10, which is how much money we'll have at the beginning of the 10th year, is just going to be equal to 10,000 times it by 1.05 raised to the 10 minus 1 power. That is just going to be equal to 10,000 times it by 1.05 raised to the 9th. Okay? And there you go. That's how you would answer this question about compound interest using the properties that we know for geometric sequences. Okay?